So today we're going to be taking a look at Euler's totient function, right? So this is the symbol phi. So this function phi maps non-negative integers to other non-negative integers, right? That's the domain and range of the function. Okay. And n, of course, I mean, yeah, that's given, right, from this function. But I mean, I've never seen 0 being used for the domain. I don't think it's defined either, but okay, so you know what, I'm just gonna this is gone. Just maps like the positive integers to the non-negative integers. So basically phi of n is the number of non-negative integers less than n which are co-prime to n. This is like a hand wavy definition. I'm not like going into officials right now. We'll go into them like about a minute later. So this is the basic definition, right? So if you wanted to find, say, phi of phi, right, so you do like, so the procedure for that would be to write down all the non-negative integers less than n, so less than 5, which is 1, 2, 3 and 4, and to check which of these are co-prime. And fun fact, phi is a prime number, so all of these are actually co-prime. So hence this is equal to 4. Yeah, so I hope you get how I did that. But you can't do that for like larger numbers. You need a proper definition for it. So this is again a hand wavy definition. So we improvise this definition a bit. So phi of n is the number of non-negative integers less than n which are co-prime to n. But okay, so I'm not going to rewrite it all again, right? But what I'm going to do is, I'm going to be smart. I'm going to rub off this definition, this example. I'm going to keep improvising it such that the GCD of n on non-negative integers a less than n, let's call that a, such that the GCD of n and a is equal to 1. That's a bit more of an official definition, but it's still doing the same thing pretty much. You're not getting say an explicit form for the Euler totient function. But now let's see, right? So the phi of phi, looked at it from this perspective, so we'll have 1, 2, 3 and 4. Now it's much easier for a computer to do, right? So you take every number in the set, you say, okay, so what's the GCD of 5 and 1? That's equal to 1. And the same will be for these. They'll all be equal to 1, FYI, because you know that they're co-prime. So anyways, hence this is equal to 4. Oh, by the way, that's true for all prime numbers, right? Anyways, that was just an example, right? But regardless, this is a bit of a more official, so to speak, definition. Oh, and of course, we define like phi of 1 to be equal to 1. I think that's like the general definition, which is agreed upon by most people. But I don't know, that's what I do. Anyways, okay, so from here we should, you may think that this is a good definition, right? For smaller numbers like 5, 10, or like maybe even 15 or 20, this is a good definition. You can make do with it. But see, it doesn't work out for large numbers. Like, for example, take 420. Coincidence. Anyways, so you'd have to list out a lot of numbers for that, right? You'd have to check a lot of GCDs and all. I mean, as a human, that's easy to do, but that's so many numbers, you'd probably want to write a computer program for that. And if you were to write a program for that, then that would be kind of dumb, to some extent. Anyways, because that will take a lot of processing power and all. Really a very bad program, like no efficiency whatsoever. Anyways, so that's why we need like an explicit formula for this, and we have a couple. I think there's like a lot of formulas for this, but the one that I like the most, which is like it holds for general, is okay. So yeah, this factor is kind of important. Phi of 1 is 1 because it's like you can't really see the non-negative numbers before 1, right? So this is just like by definition. Anyways, so for n, so we say that let n be equal to, okay, so p1 to the alpha 1 times p2 to the alpha 2 times p3 to the alpha 3 all the way to pk to the alpha k, where pi are all distinct primes. I'm doing this off my head, by the way. I don't really Wikipedia articles, the too much English. I can't comprehend it. Anyways, right? Are distinct primes, right? And alpha I are just like their powers or something. But that's pretty much the definition of the way we write a number. So that's just the prime factorization of the number and written in a fancy form. But anyways, so we use this prime factorization, right? So we define phi of n. Well, I think you can derive this formula probably like use induction or something. Would you use induction? I don't know. Phi of n is equal to yeah, so the formula goes like this, right? So the number, right, times 1 minus 1 upon p1 the alpha 1, then 1 minus 1 upon p2 to the alpha 2 all the way to 1 minus 1 upon pk to the alpha k. You can write that as a better form. N, then the product, that's a capital pi, by the way, not a smaller pi. That's not pi, yeah, the square root of g. That's not yeah, anyway, so that's like for yeah, k going, no, not k, let's use another index, let's use I, right? So I goes from 1 to k of 1 minus 1 upon pi, okay, to the power of alpha subscript I. So hopefully you can read that formula. That's like just a formal way of writing. It's basically this thing, right? So this makes calculating the totient function for like larger numbers, like say you were to take 69 for example, arbitrary example, no biases here. Anyways, that would mean that so you've taken 69, right? So if you were to like calculate all the numbers up to 68 and see the GCDs, you could probably do it. It would take you a minute and all, but that's a long time. But using this technique, phi of 69, it goes down to phi of 23 times 3, right? That's the prime factorization of 69. If you didn't know, then I don't know what to tell you. Please just know it. Now we use this definition, right? So 23 is to the first power, first of all 69, right, times 1 minus 1 upon 23 times 1 minus 1 upon 3. Alright, is that good? Now it's not that tough to simplify that. 69 times 22 upon 23 times 2 upon 3. Now these two multiply together to cancel this one out. Then you get 22 times 2, which is 44 as your result. Anyways, that's that's actually, wow, that's kind of nice. I never thought about that. Anyway, so that's in my opinion, the best definition of phi of n, right? Because this is a hand wavy definition. You could not possibly want to use it for like larger numbers. Counting is like really slow and tedious. This is a really good definition because it doesn't assume anything about the number itself. Anyway, so this is like let's see, a prequel to like the main video that I'm planning to do after this, probably, yeah, because that one's like yeah, it's like something I thought of. So maybe you'll see it in the next video. So yeah, this was pretty good. This is just like an introduction to the Euler totient function. It has a lot of applications and all, you know, number theory basically. This is really cool. Anyways, yeah, nice.